Hello, I'm Scott Turner, and I'm Director of Science Programs at the National Association of Scholars. And this is the Week in Science for the 12th of June, 2025. In today's episode, we have to take our obligatory look at the ongoing complaints about the Trump so-called war on science. It's not a war, really, but that's what it's being called. And, irony alert, one of the principal complaints is how the intellectual independence of scientists is supposedly being compromised by those budget cuts. We'll see about that. There's also been a lot of chatter about a recent study that supposedly pinpoints where the, quote, math gender gap originates, close quote. And we'll have more to say about telescopes and how astronomy is not being crushed. Okay, let's jump in. There they go again. Really, how tone-deaf do you have to be to write for Science magazine? That question was plumbed to new depths in a pair of articles in this week's edition of Science. First out of the blocks was this editorial titled Strangling Intellectual Independence by Michael Harris, a professor of higher education at Southern Methodist University. It's all Donald Trump's fault, apparently. According to Harris, two trends are coming together in a perfect storm to just wreck everything. Not only is academic freedom being subject to, quote, politicized attacks, unquote, the money is being taken away. Katie, bar the door. Well, I hate to be the one that breaks the news. Science gave up its intellectual independence in 1950, when the federal government decided to Sovietize the academic sciences. At that time, science entered into the classic Faustian bargain. We will give you money beyond your wildest dreams, said the government, and science accepted the bargain. The feds have largely delivered on their end. We now funnel more than $100 billion annually into academic science. But money always comes with expectations. And those expectations have always been political. Government is inherently political. As long as everyone's politics aligned, scientists were happy to take the money and dance to the tune. But now the politics have changed. The piper is calling a different tune. By allowing itself to become totally dependent on government, science itself strangled its own independence 75 years ago. Now, I'm all for intellectual independence, but you do come off as kind of hollow when one hand is shaking a fist while the other hand is held out for the money. Second up is this news article titled, quote, Science's reform movement should have seen Trump's call for gold standard science coming, critics say. This was by Kathleen O'Grady. People trying to make science better and more honest apparently were just played for fools. Apparently, science reform is now a bad thing, because of Orange Man Bad, I guess. Some background. For some time now, there have been troubling signs that all the money lavished on science over the decades has not been producing more or better science. Rather, it's been funding a simulacrum of science. American scientists publish a lot of scientific papers, 15 million of them from 1990 to 2022 by a rough estimate. By some estimates, as much as 90% of those papers are worthless because of inconsistent methods, poorly executed experiments, and shoddy analysis of results. In short, that 90% are papers that don't meet the supposed gold standard for good science, namely reproducibility. There's a name for this: science's irreproducibility crisis. The irreproducibility crisis calls into question the integrity of the entire scientific literature, and that's led to an erosion of public trust in science, and an erosion of lawmakers' willingness to fund science. So, some scientists have been making good faith efforts to try and restore that integrity. Scientists policing themselves, essentially. Among the leaders of this self-policing movement has been the Center for Open Science, and they've laid out some elementary principles for scientists to follow. Things like publicly registering hypotheses before an experiment is done, or ensuring that experiments are structured so the hypotheses can be falsified and tested by other scientists. There are a total of 9 of these recommendations. Sounds pretty good and responsible, right? And then the Trump administration had to ruin things by endorsing the recommendations of the Center for Open Science in an executive order titled Restoring Gold Standard Science. Suddenly, the Center for Open Science was no longer a conscientious group of scientists trying to bring back science's waning integrity. Now, according to Kathleen O'Hara, scientists should have known better. Because President Trump has endorsed the recommendations of the Center for Open Science, they have become toxic. According to one observer from the University of Bristol in England, being in favor of integrity and science is all good, but, quote, let's make sure that it isn't done in a way that inadvertently makes us useful idiots of an anti-science movement. Useful idiots? That's got to hurt. In case you're having trouble following the logic here, the claim is that Trump's gold standard science executive order is just a way for the Trump administration to impose its political agenda on science. Worse, it provides the administration the means of punishing scientists who don't toe the party line, whatever that is. And that's put the Center for Open Science into a bit of a pickle. They felt compelled to issue a statement distancing themselves from the presidential endorsement of the very things that they had been advocated. Okay, that's awkward. In fact, the enforcement of research integrity was ramped up significantly under the Biden administration. But never mind that. So is it just Trump derangement syndrome that's driving the backlash against the science gold standard executive order? After all, when the science that goes into making science-informed public policy is largely shoddy and irreproducible, isn't that a problem? And shouldn't that science be held to the gold standard? And are the goals of the Center for Open Science undermined just because they have been endorsed by the Trump administration? If you're confused, well, so am I. Next up, what about boys and girls and mathematics? There's been a lot of angst the past several years over the mathematics gender gap, in which boys outperform girls in mathematics. People are scandalized by this, supposedly because it indicates some kind of systemic oppression at work against girls, which channels them away from careers in science and into other socially favored activities, like being wives and mothers, I guess. It's exercised people so much that when Larry Summers, then president of Harvard University, quote, argued that men outperform women in maths and sciences because of biological difference, and that discrimination is no longer a career barrier for female academics, close quote. This is according to this article titled Why Women Are Poor at Science by Suzanne Goldenberg in the January 18th, 2005 edition of The Guardian. This drove many of the Harvard women faculty to the fainting couch, and the ensuing furor was so intense that it cost Larry Summers his job. And so the controversy has been smoldering for years. Are there really biological differences between men and women in aptitude for mathematics and science? Or is it some kind of socialization that explains the difference? Is it a form of disparate impact theory, in other words? Either way, it's an uncomfortable dilemma that has been left smoldering for years. It's not that women are not going into the sciences generally. It's mainly in fields like physics, engineering, and mathematics that the proportion of women tends to be lower than their demographic representation. In the life sciences, on the other hand, women tend to be overrepresented compared to the demographic. But that's a topic for another day. This week's Nature magazine reported on a major study just completed that pinpoints when the so-called mathematics gap emerges. The study reports the, quote, rapid emergence of a math gender gap in first grade, unquote, and was carried out for school children in France. This was a 4-year longitudinal study of more than 2.5 million first and second graders, which followed cohorts of children through their first few years of school. What they found was a striking divergence of boys' and girls' mathematics test results. This graph shows how the performance of boys and girls differs as the cohorts move through the first year of school up into the start of the second grade. When the students start school, boys and girls perform roughly the same on math tests. In fact, girls slightly outperform boys. By the start of the second year of school, though, boys are strongly outperforming girls. So the data seem quite striking and quite strong. The mathematics gap emerges in the first 2 years of school, and it emerges strongly. So what does this mean? The authors of the study naturally take this as evidence of systemic bias against girls from the very beginning of school. And clearly, they conclude, intervention has to be undertaken from the moment children start school, and maybe even intervention prior to beginning school. Wait, intervention? What is this, some pathology like alcoholism? Their results could just as easily be interpreted as supporting Larry Summers' speculations. Brains are developing rapidly through young childhood, after all. Isn't it reasonable to suppose that brains of girls will develop along a different trajectory than boys' brains will? And might not that be manifest in an emerging statistical facility of boys for the mental skills that underlie strong performance in mathematics? Nothing's proven here, by the way, but we're scientists. It's just a different way of interpreting the data. All we're doing is offering an alternative hypothesis, aren't we? Which raises a question we probably should be asking before making our educational interventions, especially in young children. Why on earth should we expect 50% of mathematicians to be women? Why the cookie cutter? Asking the question in this way no way excludes women from careers in mathematics and physics and chemistry. There are many women whose aptitude for mathematics outstrips that of many men. That doesn't exclude women. All it means is that there will be fewer women than men among the top performers in mathematics. And isn't everybody best served by cultivating talent rather than engineering the profession with an ideological cookie cutter? In last week's episode, we mentioned astronomers' distress over the Trump administration cutting NSF funding for one of 2 gravity wave telescopes. I pointed out then that the NSF really didn't need to fund 2, given that there were other gravity wave instruments scattered around the world, including in Italy, Germany, and elsewhere. And that meant that gravity wave observations could continue, and less expensively than it would have had 2 gravity wave instruments been funded. This week's Nature magazine, for the 11th of June 2025, has its own feature about telescopes, which fills out the state of astronomy a little bit better. The article, by David Castelvecchi, describes a major telescope that will host the world's largest digital camera and how it will transform astronomy. It brings the news about the new Vera Rubin Observatory, which is located at an elevation of 2,650 meters in the Andes in Chile. The Rubin telescope brings a number of interesting innovations to its construction. Among them is the size of its digital camera sensor, which shoots images at 3.2 gigapixels resolution. That's 3,200 megapixels. The size of the camera itself is on the order of a small automobile. It's going to be dedicated to a mission called the Large Synoptic Survey. It's intended to map the comings and goings of stars and other celestial objects over a period of 10 years. And it's going to provide a picture of the dynamics of the observable universe that has never before been possible. That means it's going to have to survey the entire night sky once about every 4 days or so. The very large digital camera is going to be an important part of that. The larger the sensor, the more sky it will be able to take in with each shot. But the Rubin telescope also brings other innovations in construction and design. For one thing, it's highly maneuverable. By carefully balancing weights, the telescope will be able to change positions very rapidly in about 40 seconds or so. More conventional telescopes would require several hours to reposition. The Large Synoptic Survey is scheduled to download its first image in just about 1 week. Stay tuned. The NSF and the European Space Agency contributed to the construction of the Vera Rubin telescope, and a significant part of the cost of the Large Synoptic Survey is being borne by private philanthropy from the Charles and Lisa Simoni Fund. Also, in last week's episode, I spoke about another unpopular funding decision by the new NSF to scale back on planning for the large Mauna Kea telescope in Hawaii and to shift funding to the Giant Magellan Telescope, yep, that's its actual name, high atop the Chilean Andes. This week's Nature magazine adds more to that story. The Mauna Kea telescope was part of a broad international effort known as the 30-meter telescope, the TMT International Observatory. The 30 meters refers to the diameter of the reflecting mirror that gathers light from the sky and focuses it on whatever is capturing the image. In the Vera Rubin telescope, that's that gigantic digital camera at the heart of it. The big quest in optical astronomy is to build telescopes with ever bigger mirrors. There's a good reason for this. The larger the mirror, the better images the telescope can capture. And this makes astronomers happy because it tells us more about that fascinating universe. There are actually a lot of telescopes around the world that have very large mirrors. The mirrors are made up of numerous hexagonal submirrors, which can be adjusted using computer control to adjust focus and correct for things like optical anomalies in the atmosphere. These telescopes are engineering marvels, without doubt, and good science has come from all of them. The Vera Rubin telescope, already mentioned, is one of them. For various reasons, all these telescopes have to be located on high mountains at subtropical desert latitudes. The best sites seem to be in the southern hemisphere, and the NSF has a hand in all of them, as do the Europeans, which, through the European Southern Observatory, maintain several sites in the Andes. There's been a kind of space race over the past several decades to build telescopes with ever larger arrays of mirrors. The first were the so-called large telescopes. That's literally the formal name. Astronomers are like that, I guess. Some of the earlier large telescopes had mirrors on the order of 8 meters in diameter. That's about 26 feet. Another is the Southern African Large Telescope, located about 400 kilometers from Cape Town in South Africa's desert interior. Its mirror is about 11 meters in diameter, or about 36 feet. For a time, the South African telescope was the largest large telescope in the world. But eventually, the quest turned to the Very Large Telescope, or VLT, Again, that's its formal name. The VLT is located at the Paranal site atop a mountain in Chile. It combines several large telescopes into an array that increases their collective mirror diameter. Those adjustable mirror arrays in the unit telescopes, as they're called, enables the 4 telescopes to function effectively as one. As I've said, these are engineering marvels. The ESO's Very Large Telescope consists of 4 large telescopes, each with a mirror diameter of about 8 meters. Here's a fun fact. The accommodation for visiting scientists and staff at the ESO's Very Large Telescope, the Residencia, was one of the location sets for the James Bond movie, Quantum of Solace. The architects of the Residencia conceived it as like a hotel on Mars might look like. Elon Musk, call your office. Naturally, the Very Large Telescope was going to be succeeded by the next generation, the Extremely Large Telescope. Again, that's its formal designation. These are intended to have effective mirror diameters of 30 meters, or about 90 feet, and the aim is for a mirror diameter of 38 meters, or about 125 feet. The Mauna Kea telescope, the one for which the NSF has pulled funding, was intended to be North America's ELT. Combined with the Chilean ELT, this would give astronomers access to the entire night sky. But, as I said last week, the biggest obstacle for Mauna Kea is issues over indigenous land rights. The NSF has not pulled out of the Extremely Large Telescope quest, though. It's just prioritized for now the giant Magellan Telescope in the Andes, which would have a mirror diameter of about 28 meters. Okay, it's not 30 meters, but it's still extremely large. If the political obstacles at Mauna Kea can be cleared away, the door is still open to begin planning for the 30-meter telescope in Hawaii. But if they cannot be cleared, the plan is to move the Northern Hemisphere ELT to the Canary Islands. So, what's the picture for the future of astronomy in the Trump war on science? There's actually a lot of activity worldwide around building new telescopes, and most likely, astronomers will not be left in the cold. It's important to note that every single one of these projects is a major international collaborative effort between multiple countries and including a lot of private philanthropy. So there really is no such thing as an American telescope or a European telescope. They're all joint ventures. The key to moving astronomy forward, therefore, is not more money, but to refine the working relationships between all of the collaborative partners. And that's probably a bigger challenge than the engineering ones, to be honest, but it's still the way forward. Okay, that's it for the Week in Science for the 12th of June, 2025. I hope you enjoyed this video. Feel free to put your thoughts and questions in the comments section. We like to have comments and to respond to them. And if you liked this video, tell your friends and share it on your social media. This video and all the videos for the Week in Science are hosted at the National Association of Scholars YouTube page. There are lots of other interesting videos there as well, and you can subscribe to us there so you can be notified when new content is posted. And there's lots more interesting commentary and articles on a variety of topics at the National Association of Scholars website at nas.org. Pay us a visit there. You might even consider joining us as a member. And if you're already a member, thanks again for your ongoing support. Until next week.